Hello guys, welcome to my YouTube channel. Today we are gonna learn about how to find arclength of a curve. So let's start. So first we will see what is a curve. So curve is an object which is similar to a line but that doesn't have to be straight. For example, suppose this is a curve and suppose this is also an example of a curve which is not a straight line. So now how to find arclength of this curve? If it is a straight line, then we can use a scale to measure the length, but in case of curve, it is not possible. So we use a formula to find arclength of such curve. Before beginning, let's see which type of curve we can find the arclength. So let's see what is the first condition. The first condition is that the curve needs to be a smooth curve. So what is a smooth curve then? Smooth curve is any curve whose first derivative is continuous. Okay. So let's write down this definition. Smooth curve. It is a curve whose first order derivative is continuous. That means dy by dx is continuous. If you want a separate video on how to find continuity of a function, then I will share it later. Okay. So now we will see what is a smooth curve with an example. Okay. For example, if y equal to log x is a curve, okay, we will check if it is a smooth curve or not. So to see what is the definition, the definition states that dy by dx should be continuous. Okay. So we will see what is the value of dy by dx. So we know this value is equal to 1 by x. Now see, this dy by dx is not continuous. Okay. At which point? At x equal to 0 point. Because at x equal to 0, this function will be undefined. Okay. So we cannot find arclength of this function y equal to log x. Okay. So now let's see another function for which we can find the arclength. Okay. So I'm writing question. Find arclength of the curve y equal to 4 root 2 by 3 h to the power 3 by 2 minus 1 and 0 less than x less than 1. Okay. So to find arclength, what is the first step? The first step is that to check if the curve is smooth or not. Okay. So let's first check. So what will be the value of dy by dx? So let's find out this one, dy by dx. See here, the constant term is 4 root 2 by 3. So the constant term will remain the same. Then derivative of x to the power 3 by 2, then minus derivative of 1. Okay. Now this value is equal to 4 root 2 by 3 and derivative of x to the power 3 by 2. So how to find this one? We know the general formula that derivative of x to the power n with respect to x is given as nx n minus 1. So we will use that formula. So it will be nx n minus 1 minus. Now the right hand side part, this part is derivative of 1 with respect to x, which is equal to 0. Okay, now let's solve this one. 3 and 3 will be cancelled out, and this 2 and 4 will be cancelled out. Okay, so now this value is 2 root 2, and this is x to the power 3 by 2 minus 1. This will be half. Okay, so see, now this function is continuous. Okay, you can see this by drawing the curve 2 root 2 x to the power half. Okay, so now we saw that this function y is a smooth curve, so we can find the arc length as arc length. Okay, so what is the formula for arc length? The formula is given by L equal to a to b root over of 1 plus dy by dx whole square dx. Okay, so now see what is the value of a to b. It is the limit of x on which we have to find the arc length. So again, going back to the question, what is the limits for x? This limit is 0 to 1. Okay, so we will use this limit as 0 to 1. Now root over of 1 plus dy by dx. What is the value of dy by dx? This value is 2 root 2 into x to the power half. Okay, so use this value 2 root 2 x to the power half and square. Okay, so next let's see, this value is equal to how much? It is 1 plus square of 2, it is 4, then square of root 2 is 2, then x to the power half into 2 or square of x to the power half. So what is this value? This value is 1 plus 8, and this is x to the power half into 2, so this value is equal to 8. Okay, so now see what type of integration it is. It is 0 to 1 root over of 1 plus 8x dx. Okay, so we will integrate this one using method of substitution. Okay, so what to substitute? We will substitute 1 plus 8x as t. Okay, now we will differentiate both the side with respect to x or t on our convenient. Suppose I am differentiating it with respect to x, then I will get d by dx of 1 plus 8x, and the right hand side will be dt by dx. Now, what is this value now? D by dx of 1 plus d by dx of 8x, it is equal to dt by dx. Now, this value, now derivative of 1 with respect to x, it is a constant, this value is 0. Now, here it is in form of this form, it is in form of cx. So, c is a constant, c value is 8 here. So, this 8 value will be okay. Now, derivative with respect to x. So, see, now what is this value? This is 0 and this value is 8. and derivative of x with respect to x is 1. It is equal to dt by dx. So we can multiply this dx here and we can tell that dx 8 dx equal to dt. So from here find the value of dx. It will be dt by 8. Okay, so now I got the substitution for dx. Okay, so what will be the next step? Next step will be changing this limit. Okay, now this limit is for x value. X value is from 0 to 1, so we will change the limits. Okay, so how to change the limits? Now we will use this formula and we will change the limit. So see, what is the lower limit? The lower limit is 0. So when x will be 0, at that time the value of t, it will be how much? Huh? Use this expression here. It will be 1 plus 8 into 0. So it is equal to 1. Similarly, next take the low upper limit. The upper limit is x equal to 1. So t value will be substitute here. It will be 1 plus 8 into 1, that is 9. Okay, now we have got all the substitution values. Okay, so now we will substitute all these values. Okay, so first the integration value will be first change the limit, write the limit of t. So what is the limit of t? T is limited from 1 to 9. Okay, so left hand is 1 to 9. Then this 1 plus 8x is t. So this value will be root t. Then next term is dx. So dx value. What is the value of dx? Dx value is equal to dt by 8. Okay, so use this value. So this is dt by 8. Now see, this 1 by 8 is a constant and it has no real in the integration. So we'll take this outside. And what is the value of root t? Root t is t to the power half. Okay, so now after integration we will get t to the power half. The integration formula is t to the power half plus 1 by half plus 1. You can remember the general formula for x to the power n, where integration of x to the power n is equal to x to the power n plus 1 by n plus 1. So instead of x, I have used t here. Okay, and in the right hand side, we'll place its limit. Okay, so now let's solve a little bit more. Now this t to the power half plus 1, this value is equal to t to the power 3 by 2. Now this half plus 1 is again 3 by 2 and the limits are 1 to 9. Now 3 by 2 here is a constant, we can take it outside, then the value will be 2 by 3. Now this is t to the power 3 by 2 and the limits are from 1 to 9. So on bit solving, this will be 2, 4 and now this value is 12. Now put the limits. First take the upper limit. It will be 9 to the power 3 by 2 minus at t place take the lower limit. It will be 1 to the power 3 by 2. Okay. So now let's see what is this value. You can use the standard calculator or you can use the scientific calculator to find this value of 9 to the power 3 by 2, or else you can use a trick that what is this value? It is 3 by 2. Okay, so we can write it as 9 to the power half and 3, and similarly here also I can write 1 to the power half and 3. So what is the benefit of writing this? Now we know that 9 to the power half, it is root over of 9. Okay, for that reason I have taken the power as half into 3. Okay, so what is this value then? 9 to the power half. This value is root over of 9. Okay, to the power 3, and similarly here also it is root over of 1, power is 3. So Now what is this value? Root 9 is 3. 3 to the power 3 minus root 1 is 1. Is 1 to the power 3. Okay. So after solving, we will get 27 minus 1. Okay. So on solving, this value is 26 by 12, and on furthermore solving, it will be 13 by 6. Okay, which is the required arc length of the curve. If you want more questions on this arc length of curve, then I will share at the end of this video. Thank you.